Sustainable pest and weed management is a fundamental pillar of regenerative agriculture, integrating ecological principles to reduce dependency on synthetic inputs while fostering long-term resilience. Traditional pest and weed management strategies in industrial agriculture rely heavily on chemical pesticides and herbicides, which often lead to negative ecological consequences such as soil degradation, loss of biodiversity, pesticide resistance, and contamination of water sources. Regenerative agriculture systems, in contrast, view pest and weed pressures as symptoms of an imbalanced ecosystem rather than isolated problems. By addressing the root causes, such as depleted soils, monoculture cropping systems, and disrupted natural predatory-prey relationships, small-scale farmers can manage these challenges more effectively and sustainably. Integrated pest management, or IPM, is a systematic approach to managing pest populations that prioritizes prevention and long-term ecological stability over immediate chemical intervention. Unlike conventional pest control, which often relies on blanket pesticide applications, IPM employs a layered strategy designed to suppress pest populations while preserving beneficial organisms and maintaining soil health. The foundation of IPM is the concept of economic thresholds. Not every insect on the farm is a pest, and even those that are considered pests do not always require intervention. Farmers practicing IPM assess pest populations based on whether their numbers reach a level where they cause economic damage. This prevents unnecessary applications of pesticides, which can disrupt beneficial insect populations, encourage pesticide resistance, and degrade soil and water quality. At the core of IPM is the emphasis on prevention. A well-managed biodiverse farm is naturally more resistant to pest outbreaks. Healthy soil supports vigorous plant growth, making crops less susceptible to stress-related pest infestations. Crop rotations interrupt the life cycles of pests, and soil-borne diseases prevent their buildup over time. Intercropping and companion planting can create physical and chemical deterrents, confusing or repelling insect pests. Additionally, habitat planting, such as hedgerows and flowering strips, support populations of beneficial insects and birds that act as natural pest controllers. When pest populations exceed economic thresholds, farmers following IPM principles apply targeted control measures in a stepwise manner. Physical and mechanical controls such as row covers, insect traps, and hand removal are the first line of defense. If these methods are insufficient, biological controls such as introducing predatory insects or applying microbial biopesticides are considered. Only when all other measures fail are chemical controls used. And even then, IPM encourages selective, low toxicity applications to minimize negative impacts on non-target organisms. Successful pest and weed management begins with accurate identification. Misidentifying pests can lead to unnecessary interventions that disrupt beneficial insect populations, while failing to recognize invasive weed species can result in uncontrolled competition that stunts crop growth. Farmers must develop the skills to correctly distinguish between harmful and beneficial organisms, as well as between aggressive weeds and those that contribute to soil health and biodiversity. Pest identification is a complex process that goes beyond simply recognizing an insect or disease. Farmers must also understand the life cycles of pests to determine when they are most vulnerable to control measures. Most pest species, such as aphids, whiteflies, and caterpillars, have specific stages in their development when they are more susceptible to predation or microbial controls. Similarly, certain soil-borne pathogens become problematic only under specific environmental conditions, such as excessive moisture or nutrient imbalances. In addition to pests, it's crucial to recognize beneficial insects that contribute to pest suppression. Many predators and parasitoids, such as ladybugs, lacewings, and parasitic wasps, play an essential role in naturally regulating pest populations. The presence of these species often indicates a balanced ecosystem where natural pest control mechanisms are functioning effectively. Weed identification is equally important. Not all weeds pose a direct threat to crop production, and some, such as nitrogen-fixing legumes or deep-rooted dynamic accumulators, can even contribute to soil fertility. However, certain aggressive species such as bindweed, pigweed, and Johnson grass can quickly dominate cultivated fields and outcompete crops for nutrients, sunlight, and water. Understanding whether a weed is an annual, biennial, or perennial informs the most effective management strategy. Annual weeds, for example, can often be controlled by interrupting seed production, while perennials require more extensive suppression efforts to weaken their root reserves. By taking a proactive approach to pest and weed identification, farmers can make more informed management decisions. Regular scouting and monitoring allow for early detection of pest outbreaks, enabling timely interventions before populations reach damaging levels. Similarly, recognizing weed species early in their development can prevent them from establishing persistent seed banks. These observational skills form the basis for an effective and ecologically sound pest and weed management program. Biological pest control is a key strategy within regenerative agriculture, utilizing natural predatory-prey relationships to manage pest populations effectively. Rather than relying on synthetic chemical interventions, biological control harnesses the power of beneficial organisms to keep pest numbers in check. This approach not only reduces the environmental and health risks associated with pesticides, but also enhances biodiversity, creating a more resilient farm ecosystem. One of the most well-known biological control strategies involves predatory insects. Lady beetles, or ladybugs, are voracious consumers of aphids, mealybugs, and scale insects. Lacewings, both larvae and adults, also prey on soft-bodied pests, while parasitic wasps lay their eggs inside caterpillars, whiteflies, and aphids, preventing further infestation. Even larger organisms, such as birds and bats, contribute to pest control by consuming insects in large quantities. Soil health plays a significant role in supporting biological control. Beneficial nematodes, for instance, target soil-dwelling pests, such as grubs and root-feeding larvae, effectively suppressing harmful populations before they damage plant roots. Fungal and bacterial biopesticides, such as Bacillus thuringiensis, or BT, offer additional biological control options by infecting and eliminating specific pest species without harming non-target organisms. However, simply introducing beneficial species is not enough. Farmers must create an environment that supports their survival. Habitat plantings such as hedgerows, flowering cover crops, and insectary strips provide food and shelter for predatory insects and pollinators. Avoiding broad-spectrum pesticides ensures that beneficial populations are not unintentionally eliminated. Additionally, maintaining a diverse landscape with perennials, native plants, and multiple crop species helps sustain the complex web of predator-prey interactions. Cultural pest management involves modifying farm practices to make the environment less hospitable to pests while promoting overall crop health. These strategies are preventative rather than reactive, reducing pest populations before they become problematic. When implemented effectively, cultural methods can significantly lower pest pressures without the need for chemical inputs. One of the most effective cultural pest management techniques is crop rotation. Many pests and pathogens have host-specific life cycles, meaning that planting the same crop in the same location year after year allows pest populations to build up in the soil. By rotating crops, especially between unrelated plant families, farmers disrupt these cycles, reducing the persistence of soil-borne diseases and pests. Intercropping is another powerful cultural strategy. By planting different species together, farmers create a more complex landscape that confuses pests and reduces their ability to locate host plants. Companion planting further enhances this effect by using species that repel or deter specific pests. For example, planting marigolds among vegetables can help deter nematodes, while basil can reduce aphid populations in tomato fields. Soil health also plays a major role in cultural pest management. Healthy soil suppresses strong, resilient plants that are better able to withstand pest pressures. Compost applications, organic matter additions, and reduced tillage improve soil structure, increase microbial diversity, and enhance plant immune responses. Healthy plants produce secondary metabolites such as alkaloids and flavonoids, which act as natural pest deterrents. Additionally, water management can impact pest populations. Many insect pests, including fungal gnats and root-feeding nematodes, thrive in overly wet conditions. Implementing appropriate irrigation techniques such as drip irrigation ensures that water is delivered directly to plant roots, minimizing excess moisture that could encourage pest and disease outbreaks. Despite our best efforts in prevention, some level of pest pressure is inevitable. When an intervention is necessary, the safest and most natural options should be prioritized to minimize harm to beneficial organisms, soil health, and surrounding ecosystems. Natural interventions include botanically derived pesticides, microbial controls, and physical barriers that effectively reduce pest populations while aligning with regenerative agricultural principles. Botanical insecticides such as neem oil, pyrethrin, and garlic extracts provide targeted pest control with minimal environmental impact. Neem oil, for example, disrupts insect feeding and reproductive cycles, reducing pest numbers without harming pollinators or beneficial insects when used appropriately. However, even natural pesticides should be used with caution to avoid unintended consequences. Microbial solutions such as Bt offer another effective intervention. Bt is a naturally occurring soil bacterium that produces proteins toxic to specific insect larvae, including caterpillars and mosquito larvae. Because it targets only certain pests, it's safe for humans, animals, and beneficial insects. Physical barriers can also be highly effective. Floating row covers prevent flying insects from accessing crops, while sticky traps can capture pests like whiteflies and thrips before they spread. Trap crops, plants that attract pests away from cash crops, can further reduce pest pressures while providing habitat for beneficial insects. Weed management in a regenerative system is about balance. While some weeds compete with crops for nutrients and space, others contribute to soil stability, biodiversity, and nutrient cycling. The key is to suppress problematic weeds without disrupting soil health. Mulching is one of the most effective techniques for weed suppression. Organic mulches such as straw, wood chips, cover crop residues create a physical barrier that blocks weed germination while simultaneously enriching the soil. Living mulches such as clover provide additional benefits by fixing nitrogen and outcompeting aggressive weed species. Cover cropping is another powerful weed management strategy. Fast-growing cover crops like buckwheat and rye shade out weeds while improving soil structure and organic matter content. When terminated at the right time, cover crops form a natural mulch that suppresses weeds for subsequent planting. Reducing soil disturbance through no-till or low-till practices also helps minimize the emergence of buried weed seeds. Tillage often brings dormant seeds to the surface, triggering their germination by disrupting the soil. As little as possible, farmers reduce the weed seed bank and maintain healthy soil biology. As we've discussed, regenerative agriculture is a holistic approach that views the farm as an interconnected ecosystem rather than a set of isolated problems to be solved with inputs. The long-term benefits of integrating regenerative weed and pest management go beyond immediate productivity. They contribute to ecological resilience, improve soil health, and economic sustainability by shifting away from chemical dependence and toward biological and cultural strategies. Farmers create systems that become more self-regulating over time. One of the most significant long-term benefits is soil health improvement. Conventional chemical herbicides and pesticides disrupt soil microbial communities, reducing biodiversity and organic matter content. contrast, regenerative practices such as cover cropping, mulching, and reduced tillage build organic matter, enhance soil aggregation, and increase microbial activity. Healthy soil retains moisture more effectively, making farms more resilient to drought and extreme weather. Improved soil structure also supports deeper root systems, allowing crops to access nutrients more effectively and reducing their vulnerability to weed competition. Another key benefit is increased biodiversity. By reducing synthetic inputs and fostering habitat diversity, regenerative farmers support a greater abundance of pollinators, beneficial insects, and soil organisms. This biodiversity contributes to natural pest suppression, reduces the likelihood of disease outbreaks, and enhances ecosystem stability. Regenerative systems also lead to economic sustainability. While synthetic inputs may offer short-term convenience, they come with long-term costs, including herbicide-resistant weed populations, declining soil fertility, and increased pesticide resistance. Farmers who adopt regenerative methods reduce their dependence on costly inputs, improve their farm's resilience, and potentially tap into markets that prioritize sustainability, such as organic and regenerative certified food systems. Perhaps most importantly, regenerative pest and weed management contributes to long-term farm resilience. A farm that builds soil health, enhances biodiversity, and fosters ecological balance is better equipped to handle environmental stresses such as unpredictable weather patterns, pest outbreaks, and market fluctuations. By focusing on prevention, diversification, and natural interventions, farmers create systems that not only sustain production, but also regenerate the land for future generations.